Hello everyone! Today we were going to resolve LeetCode Domino daily problem number 790. Domino and Tromino Tiling. It's the last domino problem, totally, because we don't have any more. And it's a medium problem in which we are given two tiles. We see image of tile 1, 2 at x1 and another Tromino type. We may rotate these shapes as we need it. So what we need to do in the final results is have all combination of tiles. Make sure that they don't have any gap. So we're given an integer a, and we should return the number of ways to tile and to xn board. Since the answer may be very large, we should return modulo of 10 to 9 plus 7. So in tiling, every square must be covered by a tile. Two tiles are different only if there are two directional adjustment cells on the board, such that extendly one of tiling has both square occurred by a tile. So as we see combination of two tiles, three tiles by two other combination, and here's terminal combination of the tiles. So totally we have output of 5. Input is 3. So what we should return is the different way we have combined this tile. So we have 5 different ways that's shown above here. Quite hard to understand. Therefore, we try to listen a good story about how to resolve this problem. In the quiet town of Tileville, residents had periodical tradition. Every year, they would expand their communal path by adding exactly 2 rows of new tiles, extending it by 1 unit in length. This year, they needed to extend the path by n units. Maya, the town's master tile, had only 2 types of tile at her disposal: rectangular dominos, 2x1, and L-shaped trominos. She needed to determine how many different ways she could complete the path without leaving any gaps. Time is finite. Maya pondered, remembered the philosophy from the book she read, 4,000 Weeks. Just as Burkeman suggested focusing on what truly matters rather than trying to accomplish everything, Maya realized she didn't need to count every possible arrangement from scratch. She noticed patterns in her previous work. For small path, n equal 1 or n equal 2, the solutions were straightforward. But for larger path, she discovered something fascinating. The number of ways to tile a path of length n was related to a solution from smaller path. Like Burkeman advised about embracing our limitation and working with them, Maya embraced the pattern. She realized she could build on her previous knowledge, using what she already knew about tiling smart path to solve the bigger challenge. Each solution determined on specific combination of solutions that come before it. We don't need infinite time or knowledge, Maya smiled. We just need to recognize the pattern in what we have already done. So as you understand from this story, the pattern that we will be using will be dynamic program. Idea of splitting our problem in multiple small problems and then build our resolution in a recursive way. So time complexity for this problem will be linear, just big O of n. The same goes for space complexity, big O of n. linear space. So for the code, we will need mode, our modulo, which will be equal 10, 9 plus 7. Then we will check the most base cases. So if n equal 1, just return 1. If n equal 2, we return 2. If n equal 0, we return 0. Next step will be initialize our DP array, which will be 1, 1, and 2. Then we will build up solution iteratively using for loop for I in range 3 and plus 1 if value equal to dp I minus 3 plus 2 multiplied by dp I minus 1 and modulated by mode. Lastly, our dp will be appended value, so we add value to it, and we will return our dynamic programming minus 1. So solution for length n. Let's run it. Let's path and let's submit. And it's very efficient. Thank you for your attention. If you have any questions, feel free to leave them down below. And have a nice rest. Bye.